Good evening. Today we will present about LPG gas leakage detector. So my name is Ahmad Adham Mazlan, and my fellow friends Nur Fiza Khalila binti Yusuf and Amir Hamzah bin Muhammad. Okay, next. Okay, for the introductions, Industrial Revolution 4.0 is what we are facing now, as well as our machines. It is where the machines are connected through a device or components that requires smart technologies such as the internet. For an example, detecting a fault in a machine or an environment. Gas leakage is a major problem in the industrial sector, in residential location, and actually uh, okay, the goal of this paper to propose a system that can detect, alert, and automatically control gas leaks. Next. The LPG gas leakage detection system is an important safety measure for public safety. The main objective of the system is to monitor the leakage of liquefied petroleum gas (LPG) in order to avoid serious fire accidents. The LPG gas leakage detection system is an important safety measure for public safety. Next. Okay. Problem of current system or applications. By using Internet of Things and recording sensor data to a remote server, the limitation of memory in the monitoring devices and the manual collection of data from the installed devices can be overcome. The IoT also helps monitoring the data in real time. For the objective of this IoT integrated LPG gas leakage monitors are follows. First, to design an innovative LPG gas leakage monitoring system that can cover 1 square kilometer of urban area. Second, to monitor LGB gas leakage condition through smartphone application from installed sensors on buildings. And lastly, to propose preventive actions through smartphones applications when the LPG gas leakage happen and do the fast action. Next. Justifications. This project proposes an idea to install monitoring application on smartphone. It is innovative because it provides easy access to the public to monitor real-time condition of LPG gas in the area. For controlling these sensors, microcontrollers are used, and the microcontrollers also act as transmitter to transmit the data to the cloud database. The information on LPG gas leakage can be accessed through a smartphone app in real time. Next. LPG gas leaking detector system overview. For the software involved in the systems, first we use Arduino IDE software, Arduino. Second, ESP826655 module. And lastly, Proteus design suits. Overall system flow. Okay, the device developed in this project can be installed near any Wi-Fi hotspot in a populated urban area. The Wi-Fi module is configured to connect with the IoT platform and provide instant visualizations of data posted by the IoT. By the diagram, we can see how the system works. For the Arduino Kits for the Arduino Kits, it contains memory, and then the server to the light buzzer, MQ5 sensor, exhaust fan, and Wi-Fi modular to the user. Okay, next. Okay, view of user interface. Okay, I proceed to
Okay.
the my friends Amir Hamzah.
Okay, thank you, Adham. Next, we move to the tool and equipment of using the LPG gas leak. First, we use the Arduino Uno. It is increase the readability of the code, is convince and organize the program. It reduces the chance of errors. It makes the program compact and small. It avoid the repetition of the set of the statement or code. It allows us to divide a complex code or programming into a simpler one. Okay, next. Second, we use the ESP8266 Wi-Fi module. This component is very important. So the function is ESP8266 module is a self-contained SoC with integrate TCP or IP protocol stack that can give any microcontroller access to Wi-Fi network. The ESP8266 is capable of either hosting an application or offloading all Wi-Fi networking function from another application processor. It is used to send the information about the LPG gas monitoring system to the user. The, the third is gas sensor. The gas sensor for detecting a wide range of gases, including NH3, NOx, alcohol, benzene, smoke, and CO2. The MQ5 gas sensor has high sensitivity to ammonia, sulfate, and benzene steam. Also sensitive to smoke and other harmful gases. So this is important to our project. Next, the buzzer. The buzzer consists of an outside case with two pins to attach it to power and ground. When current is applied to the buzzer, it causes the ceramic disc to contract or expand. Changing the disc then causes the surrounding disc to vibrate. If the buzzer starts ringing, it means there is a gas leak around. Next. Okay, after that, the next component is the breadboard. Generally, a breadboard is a rectangular plastic board with a bunch of tiny holes in it, as we can see in the picture. These holes let you easily insert electronic components to prototype example to build and test an early version of an electronic circuit like this one with a battery, switch, resistor, and LED. Next. The next is resistor for 221 ohm. The resistor is a passive electrical component with the primary function to limit the flow of electric current. For gas leaking monitoring system must use 4 resistors. The next is we talk about LED. This project use 3 light of LED, red, green, and yellow. The red LED in LPG gas leakage monitoring system used to indicate the system when the gas leak is on the dangerous level. The buzzer will automatically turn on when the red LED is turned on. The yellow LED will turn on when the gas is abnormal but not dangerous yet. The 5mm green LED will always turn on when there is no gas leakage happen or clean. This tool, a soldering iron, is a hand tool used to heat solder, usually from an electrical supply at high temperatures above the melting point of the metal alloy. The, the next is exhaust fan. The exhaust fan used to control the interior environment by venting out unwanted gas which may be present in the air. The exhaust fan can also be integrated into a heating and cooling system. The last component of this project is 60x2 LCD screen. This LCD will display the word danger after the gas detector detects more than 200 ppm.
Next is methodology. First and foremost, we made design for our system by using Proteus software by using the components stated above in table 1. After completing the design, proceed in making the programming for the system to work using Arduino. After completing both, to know or ensure it can run smoothly and properly, the programming was made and imported to Proteus to run the simulation. This is to ensure that the programming could activate the system as intended. A sensor detects gas leakage or harmful gases in the air. The red LED will glow and the buzzer will start ringing. If the gas stays in normal read, but there is a presence of unwanted gas, the yellow LED will turn on. Otherwise, the green LED will glow as an indicator for a good air quality. Fourth, when the red LED turn on, the LCD will display danger, and by using the ESP8260, Wi-Fi module and SMS will be sent out to the user as a warning. As the programming works fine in the simulation, thus the design is suitable to be made. A proper hardware or the system was made using all components as stated in the previous slide. Next, the purpose design. The design comprises of gas sensor, Arduino Uno, microcontroller board, buzzer, red, yellow and green LED light connected using a breadboard. The gas sensor detects the presence of gases such as LPG. The output value obtained in voltage is converted to ppm using the microcontroller. The MQ5 sensor is used as the LPG gas sensor. The gas threshold level set before any alert is sent to user for the MQ5 sensor is equal to or greater than 800 ppm. 800 ppm or CO is extreme exposure with symptom of dizziness, nausea, convulsion, and death within 45 minutes. The dangerous level that can be harmful for human is at 200 ppm for CO2. Both gases appears in LPG gas. Upon detecting the gas leakage, the corresponding signal will be sent to the LED lights and buzzer. The green light will go off for values below 50 ppm as safety exposure as specified by the Health and Safety Executive, while higher values will make the yellow light turn on as a precaution, and more than 100 ppm, the red light will turn on along with the buzzer. Purpose of Arduino diagram. So this is the Arduino diagram that we proposed, but we cannot run the project since COVID. So advantages, this could detect almost all of the harmful gases that may be present in the air system or in certain environment or room. It can save a lot of life, less cost, save money for a long term. It can control through IoT system at any location. Thus, it can notify users about the gas leakage and undergo safety procedures. As for the disadvantages, if the IoT is broken, users could not detect any places due to network down. There is no security attached. So this is the flowchart. First, we start, and then sensing nearby LPG gases using MQ5 sensor, and then read sensor data by Arduino. Calculate the gas leakage level. If ppm below 50, if no, yellow or red LED will turn on. If yes, green LED will turn on. If the ppm is 51 to 199, the yellow LED will turn on as a precaution. If no, the green LED will turn off. Next, if ppm above 200, if no, the green and yellow LED will turn off. And if yes, the red LED and buzzer will turn on, LCD will display danger, SMS will be sent to the user mobile phone. So that is the flowchart. For data analytics, the data will be sent by a system or interface to process by the cloud storage. It will manipulate the data to produce the result or information. There are two areas the data will be sent, which are from the system and from interface, which is data analytic from the system and data analytic from the user. Data analytics from the system. Below are examples of data when gathered from MQ5 sensor. The examples are shown below. Next is data analytics from the user. From the system, we process by cloud storage to provide information that will be sent to user. User can always check if any gas leakage, it will be take reading every 3 minutes. If some gas leakage occurs, the ESP8266 Wi-Fi module will send out SMS to give a warning to the user. So this is the example. Next is business opportunity to the market system. The main objective to design this system is we want people in our country live in safe condition and decrease the value of gas leakage that will cause flammable and explosion. So it have a big opportunity to market this system since most of the sector use LPG gas on daily basis. So this is our target customer. So first, household, net high-rise building, restaurant, school and universities, and factories and plants. So as for the conclusion, in a nutshell, this single project could probably save life by detecting LPG gas leakage in the air system with less cost. With the detection, it will give the user or people in certain building time to escape the room or area and call authority to take care of the issue. In hope that every building to have at least on the system in order to ensure safety of the people living or working or even learning in the building. That's all. Thank you.
Thank you.